There we go. All right. So order of operations is really one of the topics where people kind of first really see that they're struggling in math. So I want to spend a decent amount of time on this. It says that in this section there's order of operations and algebraic expressions, but I break those up. So we're going to cover order of operations. Then tomorrow we're going to review the applications that we've done. On Monday we will have the review for our first test. We'll take our first test on Tuesday, and then after that we'll get into algebra. Okay? So I like to keep these two things separated. I don't even know why they put them in the same section. All right. So today all we're covering is order of operations. So you'll see stuff if you look at this PowerPoint on translations involving variables and evaluating algebraic expressions. We're going to wait till after our first test to do that. Yeah, absolutely. No, it will not. It will not give you anything. I've actually split that assignment into two separate assignments. Yeah. All right. So order of operations. I'm sure many of you somewhere along the line learned this thing. Don't write this down, okay? Just set your pens down for now. I'll let you know when to pick them up. I absolutely don't want you to write down what I'm about to write down, okay?
So what about this? You can write this down, order operations here?
Yes, absolutely. So there's this horrible thing that you shouldn't write down called PEMDAS. It's not true, okay? It's not. But that's how order of operations get taught. And then they give you this mnemonic. Please excuse, my dear Aunt Sally. And it's supposed to stand for parentheses. Do not write this down. It's wrong. Okay? It's kind of got some truth to it, which is probably why it screws students up so bad. It is true that we have to perform the operations within grouping symbols first, and that one of those grouping symbols are parentheses. So that first part doesn't bother me so much. The second part isn't too bad. After we evaluate all operations within grouping symbols, we would evaluate the exponents, the roots, and the absolute values. It's this part that drives me nuts. Students think because of this stupid mnemonic that they're supposed to do the multiplication first and then go and do the division. That's not true. You do multiplication and division as it occurs from left to right. If the division comes first, you do the division first. If the multiplication comes first, you do the multiplication first. So this is total bogus. Okay, we don't want to think of it that way. Same with addition and subtraction. Because of this stupid mnemonic, students think you have to add first and then go back and do all the subtraction. That's not true. You add and subtract as it occurs from left to right. So this part is not true. It took me a few semesters of teaching to realize that it was this mnemonic that was making it to where my students could not correctly simplify order of operations problems. Yeah?
But isn't it parentheses first, exponents, then add and subtract as it occurs left or right?
It's
multiply and divide as it occurs
nope.
left or right?
You're going to do parentheses or all grouping symbols, and we'll talk about that because there's more grouping symbols than just parentheses. But you're going to do all the grouping symbols first, so the operations within the grouping symbols you're going to perform first. Then you're going to evaluate all exponents, roots, and absolute values. Once that's done, you will multiply or divide in the order it occurs from left to right, and then you'll add or subtract in the order it occurs from left to right. Okay? That's the real order of operations. This I'm now going to get rid of. I'm never going to mention it again because I want you to forget it. If we were machines, I would actually have you go in and physically erase it from your memory. Okay? We just, unfortunately, we're not. So this is the real order of operations. Okay? First, you perform all operations in parentheses or other grouping symbols. So step 1. Perform all operations within grouping symbols. So this means that if we have something like a set of parentheses with a 3 plus 4 in it, we have to perform the addition first, okay, because it's within a grouping symbol. But we could also have something like the square root of 16 plus 9. The square root is functioning as a grouping symbol. We have to do the addition first before we can do that square root. Also, something like the absolute value of -7 plus -3. We would have to perform the addition here before we could actually perform or evaluate the absolute value. So those can all act as grouping symbols. Also, fraction bars can act as grouping symbols. So I may have something like 2 to the power of 2 plus 3 over, let's do 81 divided by 3. Okay? I may have something like that. The fraction bar is acting as a grouping symbol. It's telling me simplify the top and then simplify the bottom. Then, if you can, either simplify the fraction or do the division. Okay? So, lots going on in that first step, but it's performing all operations that are within grouping symbols. Notice I didn't say we were going to evaluate that root. In the first step, you don't evaluate anything. You just perform the operations that are contained within the grouping symbols. It's in step 2 that we're going to evaluate the exponents, the square roots, and the absolute values. So step 2. Evaluate all exponents, roots, and absolute values. So it's in this step that if we see 3 to the power of 3, we would actually state in step 2 that that's equal to 27. If we saw the square root of 25, in step 2 is when we would evaluate that square root and say that's 5. Or if we had the absolute value of -8, it's in step 2 that we would evaluate that absolute value and say that the answer is positive 8. Okay? So step 1, perform all operations inside grouping symbols. Step 2 is to evaluate all exponents, roots, and absolute values. Okay? Once we've done that, step 1 and step 2, there can only be the 4 basic operations left: multiplication, division, addition, subtraction. So in step 3, we're going to do all multiplication or division as it occurs from left to right. Okay? So we're going to literally start at the left, go to the right. The first multiplication or division we see, that's the operation we're going to perform. And then we're going to just do that one operation, rewrite everything else, and then start over. Start at the left, work to the right, look for a multiplication or division. Once we've done all the multiplication or division in a problem, that's when we do step 4. And step 4 is similar, but it's for addition and subtraction. We're going to perform all addition or subtraction as it occurs from left to right. That is our order of operations. So any questions just on the general outline of the order of operations? Yeah.
So I guess you're going to show us an example.
Oh, yeah.
of a problem.
Yeah, we're going to do several examples of problems. You know, this here is really kind of to keep as a guide until you've committed the order of operations to memory. The way you really commit the order of operations to memory, though, of course, is by doing a lot of practice. So we're going to do several examples in class, and then, of course, you're going to have your Connect homework in which you're going to be asked to do several examples. Okay?
So this is going to be part of the first steps.
Oh, yeah, absolutely. Yep. Okay.
So is this the hard part of the class first?
Well, I would say this is the first particularly challenging thing. When I think about folks as groups and from one group to the next semester to semester, what do folks find challenging? The order of operations is one of the first things we encounter that, on average, several people will find challenging. I think a lot of it is just because it's been poorly taught for so long. Now, you know, if you were in school now, they're actually starting to get away from that mnemonic because they realize how much damage it's doing. But there have been generation after generation after generation that's learned it or, you know, committed it to memory, and then they just think they can't do order of operations problems. You know, it's really 4 steps, right? So if, you know, in junior high or whenever you first encounter this stuff, you know, now it's probably in elementary school somewhere because they keep pushing up the curriculum. But if you encountered it correctly back then you have a lot of time to work several problems and over time absorb the rules. Unfortunately, of course, you get to college and we expect you to do it in, like, you know, a couple days. So, does everybody have this written down that wants it written down? All right, so now that we have the steps in the order of operations, what we need to do is work several examples. We're going to start off with smaller examples and work our way to more complex examples. In each problem, you may not have to perform each and every step in the order of operations. There may not be any grouping symbols, so we don't have to worry about it. But we're always checking. Every time I encounter a problem, I'm asking myself, are there any operations within grouping symbols? Are there any exponents, roots, or absolute values? Is there any multiplication and division? Is there any addition and subtraction? All right. So the first one we're going to look at says 6 minus 4 times 8 minus 10. Okay? We do have a set of grouping symbols here, a set of parentheses. So we're going to have to do what's in the parentheses first. So that's going to give us 6 minus 4 times, what is 8 minus 10? Negative 2. Now, here, you're probably best off to get rid of this subtraction here. Change it to addition of the opposite sign. So now we can see we've got 2 operations left. We've got an addition and we've got a multiplication. So which one do we do first?
Multiplication.
Multiplication.
Is that a negative 4 now?
Yeah, it's a negative 4 now. So I've got 6 plus negative 4 times negative 2 gives me what? 8. Now I only have one operation left, so I need to perform that operation. 6 plus 8 is... Okay, where did I lose you? So up here? So what I did, I had 6 minus 4 times negative 2, right? So I got rid of my subtraction using my subtraction rule. I changed minus a positive 4 into plus a negative 4. Okay. Well, if I did it the opposite way, 6 minus 4 times negative 2. If I don't get rid of this, I get 6 minus 4 times negative 2 is negative 8. So now I've got 6 minus negative 8. So this minus a negative usually is more confusing. And so we try to avoid those situations. You could change it at this point if you wanted to and do addition of the opposite. And now you have 6 plus positive 8, which is still 14.
Okay.
So it all depends on how you want to do it. I usually get rid of my subtraction fairly early because it just makes it easier. But then here, 6 plus 8 gives us our 14.
Does this fall under like the pretenses of like they change it for the thing?
Not really. What you're thinking of is that division of fractions rule.
Yeah.
This is the subtraction of integers rule. So anytime we see subtraction, we can always change it to addition of the opposite sign. So
we have to do this in an inverse property, like 6 plus 4 or negative 4. Then when we go down, it would be minus. And
we will, once we hit algebra, when we were trying to clean up a final answer, when we're simplifying expressions, but we'll treat it then.
Okay.
You'll see. It's actually much easier than, because it's always at the very end of a problem. So it's not a real big deal, unlike this where it's in the middle of a problem. Yeah.
Can you say that again whenever you see that?
Sure. Whenever we see subtraction, we change it to addition of the opposite sign. So for instance, if I have A minus B, I can change this into A plus negative B. I change my subtraction to addition and the positive B to a negative B. If, on the other hand, I had A minus negative B, this would become A plus positive B. Change subtraction to addition, change the negative B to its opposite, to a positive B. Okay? It's called the subtraction rule for integers. Any questions? Oh, remember that there are pencasts for all this stuff too. So if you're having issues, there's a link on our class website. It says, "Are you ready for Mth067?" If you click on there, it goes through all the integer rules, all the fraction rules, and all the decimal
I
rules.
got the first one, A minus B to
Yeah.
plus B. I feel
So
like
the other one would be A minus negative B becomes A plus positive B.
yeah.
So here we've got 48 minus 36 divided by 6 times negative 2. All right. So the first question is, are there any operations within grouping symbols? No, right? So there's no operations within grouping symbols, right? We have parentheses, but there's no operation within this set of parentheses. And there's no operation within that set of parentheses. Are there any exponents, roots, or absolute values? No. We're done with step 2. Moving on to step 3, we want to do all multiplication and division as it occurs from left to right. So I start at the left. This is subtraction, so I skip it. This is division, so I have to do that first. It's dying. Okay. So now I've got 48 minus, what is 36 divided by 6? 6. Once again, here I've got this, I know this is going to come out negative, so I'd like to get rid of the subtraction. So I'm changing minus a positive 6 into plus a negative 6. Now I have 2 operations, addition and multiplication. So which one do I do first? Multiplication. So that's going to give me 48 plus negative 6 times negative 2 gives me what? Positive 12. I only have one operation left, so 48 plus 12 gives me 60. Any questions?
If that's a factual question, I'm going to be more confused.
Okay. If you need to ask it later, let me know. So notice that when I'm going through, I'm only doing one step in the order of operations, right? Then I'm rewriting my expression. That's really how you want to work. If you're trying to do 2, 3, 4 steps in the order of operations and then rewrite it, you're going to get lost. You're going to make more errors. So it's best to work it out step by step. The other thing is that if you're really worried about your arithmetic, check it with the calculator, right? If you're like, oh man, I can't remember the rule for multiplying integers, pull out your calculator and do -6 times -2. See what it gives you. Each arithmetic step can be done with your calculator. I'm not worried about that. I'm wanting to make sure that you understand the order of operations. Yeah.
The last part of it, which is our answer, is that where we're simplifying, is that cause
Well,
4?
right. We are simplifying throughout, right? The order of operations allows us to simplify expressions. Down here, we've performed step 4, right? Addition or subtraction as it occurs from left to right. So we did the addition. That was step 4, and that's what gave us our solution.
Because when I was writing it out, I got step 3 for that. So I was
Step 3 should be multiply or divide as it occurs from left to right. Step 4 should be add or subtract as it occurs from left to right.
okay. I have the first step is that we changed the, I'm going to go to the first one, because that was what I was writing. Change the subtraction to addition, which is the subtraction integer rule. That was step 1.
Oh, see, in our order of operations, we actually don't write that in as a step. It's something that we do. But order of operations says we perform all operations within grouping symbols, step 1. Step 2 is that we evaluate all exponents, roots, and absolute values. Step 3, multiply and divide as it occurs from left to right. Step 4, add and subtract as it occurs from left to right. All right. So moving up in complexity, I'll need the whole board for this one.
Is it going to be questions like this?
Absolutely. So we've got a bracket, and then in parentheses, -8 to the power of 2 minus 5 to the power of 2, and then a bracket, and then a division sign, and then within parentheses, -4 plus 1. All right. Well, we've got 2 sets of grouping symbols, but they're on the same level. They're not embedded one within the other. We've got this set of grouping symbols here, these brackets, this set of grouping symbols here, these parentheses. Brackets and parentheses are treated exactly the same. The only reason they're written differently is so that you can distinguish one from the other. So we are going to sit down there and
Sorry, on a calculator, you're just use the
parentheses. That's right. Whenever you see a bracket in your calculator, it would be a parenthesis.
So we put like 2 sets of parentheses.
Yeah. So here, right, we would need to do the exponents first before we do the subtraction. Here, there's only one operation in that grouping symbol, and it's addition. So those are the operations that I'm going to perform first. So I write parenthesis. Now, -8 in parentheses to the power of 2 is going to give me what? 64. Minus 5 to the power of 2 is going to give me 25. And now I've got divided by, and then -4 plus 1 gives me what? -3. In this bracket, I still have an operation to perform. I need to perform that subtraction. So 64 minus 25 is going to give me what? 39? So we have 39 divided by, and that's -3. Now we only have one more operation to perform, which is division. So we just go ahead and do that. 39 divided by -3 gives me what? -13. That's not too bad, right? As long as you take it step by step, that's the key. All of these order of operation problems. Each step is going to be a fairly simple arithmetic step. It's keeping the order of operations straight so that you make sure you do all of step 1 before you move on to step 2 and so on. And the big one is remembering that you do multiplication and division as it occurs from left to right, and then addition and subtraction as it occurs from left to right. Okay, so let me be very, very clear, because I'll have some student that does this. I don't want it to be you. When I give you an order of operations problem, you need to show me every single step in the order of operations. If you want to use your calculator to check your answer, that's fine. But if you feed it into the calculator and then give me the answer, you will get 0 credit for that problem. Okay? I'm not interested in the answer. I know the answer already. I'm interested to make sure that you know the order of operations. So that being said, if we wanted to check this problem on our calculator, we can't use these brackets. Okay? We're just going to use parentheses. So when I look at this, looking back up at the top, I put parenthesis, and then another parenthesis, and then a -8, and then I close that parenthesis to the power of 2, and so I can just hit that x squared button. That'll give me a quick power of 2. And then -5, and I want that to the power of 2, and then I close my parenthesis. And then I hit my division button, and I need another parenthesis. So I hit another parenthesis, and then -4 plus 1, so -4 plus 1, and then I close that final set of parentheses. And then I press enter, and it gives me -13. Okay? So you can use the calculator to check your work. That's fine. Don't use it to get the solution, though. Okay? If you're asked for the order of operations. There will be times when we work on application problems and we'll have a rather complex expression. If the goal of the problem is to get the solution to an application, it's fine to use our calculator for multiple steps. But when you're asked specifically to simplify using the order of operations, when it says using the order of operations, you've got to show me all your steps. Okay? All right, so here we have one, and it's actually got a fraction bar as a grouping symbol. So we've got the absolute value of 10 minus 50 all over 6 squared minus the in parentheses -4 squared. All right, so what we want to do is simplify the numerator and the denominator first. Okay? So my first step, when I look at my numerator, I see that there's an operation to perform within the absolute value. So I'm going to do that first. 10 minus 50 gives me what? -40. So the absolute value of -40 is on top. On bottom, do I want to do my exponents first or my subtraction first? Exponents first. So 6 to the power of 2 gives me what? 36. Minus, now in parentheses, -4 to the power of 2 gives me 16. Now, I can go ahead and take the absolute value of -40, which is 40. And then 36 minus 16 gives me 20. The fraction bar tells us to divide. So if we can divide evenly, that's what we want to do. So 40 divided by 20 gives me 2. Any questions? It's not too bad, right?
Dude, I'm so glad I'm in here. Like the last class I took, she like just wrote it on the board. Didn't do like any of the little things you do, explain how you gotta do
Yeah.
it to get way
No, there's a lot going on, so we want to make sure we understand. So, all right. So, let's look at this one. Now, you'll notice that there's something different on this one, or at least hopefully you've noticed. We've got a set of brackets, and then within that set of brackets, we have a set of parentheses. Whenever you have a set of grouping symbols embedded within another set, you always do the innermost set first and then work your way out. Okay? So here we've got -13 plus, and then a bracket. Oh, nope. We've got +3 and then a bracket. And then 11 plus, and then a parenthesis, and then -15 plus 10, and then a parenthesis, and a bracket. Okay? So, once again, when I have a set of parentheses embedded within another set, I need to do the innermost set first. So, we're going to do that operation first. So, we've got negative 13 plus 3 and a bracket, 11 plus, now, here negative 15 plus 10 is negative 5. Good. So we've completely done the operation within this innermost set of parentheses, and so now we start working our way out. We still have an operation to perform within grouping symbols, so we do that. We're going to get negative 13 plus 3 times, and then 11 plus negative 5 gives me 6. Good. Now remember, parentheses and brackets are the same thing. So when I see a number right next to another number in parentheses, what operation is that? Multiplication. So I do the addition or the multiplication first? Multiplication first. So that's going to give me negative 13 plus 3 times 6 is 18. And now I only have one more operation left. So negative 13 plus 18 is 5. Excellent. Any questions?
On the last one? Yeah, that one. When we get over from like the 10 to whatever that is, 50, yeah, 10 to 50, and we go over and we have the 40, we don't touch that anymore, only because there's only one variable up there.
Right. What we've done is we've done one step in the order of operations. We did the operation within grouping symbols and brought our answer over.
Yeah.
And then in the next step, we actually evaluate the absolute value.
Yeah, that's what I was wondering, like, because at the end we ended up with 40 over 20.
Yep.
Now, since there's only one single variable up there, we don't touch that anymore.
That's right. Since there's only one number, right? Only one number up there. So all we can do, once we've completely simplified the numerator to a single number and completely simplified the denominator to a single number, that's when we can do the division.
And we can skip the step of finding the 6 squared and then just go to 4 and then find the 7.
Well, I actually did that, right? 6 squared is 36, so I found that and wrote it down.
Right, so then next you wouldn't have to move the 4. You know what I'm saying? Like,
Oh, we don't have to do these individually. No. No, we can do both of those exponents at the same time. Yep. Other questions? All right, so go ahead and try this one. Good. Give about another minute. If you're getting stuck and you're not finding the answer, first try making sure that you're changing all the subtraction to addition of the opposite sign. May make it a little easier for you. Sure, absolutely. They'll start off kind of smaller and then just kind of work up in complexity in the homework. All right, so if you have an answer, make sure you've entered it, and if you don't have an answer, make sure that you at least guess, so I know that you're here and attempting the problems. Going once, going twice, got two more. Okay, there we go. What's going on here? There we go. So good. We got 95%, right? The answer should be 0. Okay. How about this one? It's a fairly straightforward one. So have to be a little careful. Once again, if you're using your calculator, just make sure that you're showing each step in the order of operations. Especially in class, because if you don't have examples to work from, then when you get to your homework, if you've just been punching these in your calculator, you're not going to have enough examples to work from. All right, so I'll give you about 30 seconds. Well, here you did addition, but you didn't make it the opposite. So that should be -10 plus -25. But your answer's correct. There we go. Excellent. So we should have -35. Good. How about this one? Let me write it up here for you. Oops. Right. Yep. Okay. We did a lot of the individual steps, but we never really combined it. We might have kind of covered it kind of quickly at the end just to give you a head start. All right. Yeah, because sometimes at the end of 034, if I have time, I'll cover it just to kind of give people a heads up. Question? Be about 30 seconds. All right, so if you have an answer, make sure you've entered it. All right, so this one's pretty good. So let's go ahead and take a look at this one. So one thing that can be helpful is if first you convert each of your subtractions to addition to the opposite. Okay, so I'll write 55 minus 3 becomes plus negative 3. And then I've got 2, and then minus 6 becomes plus negative 6. Okay? It can be helpful sometimes, so that's why I tend to do it. So now I know that I have to do what's inside the grouping symbols first. So that gives me 55 plus negative 3 times, and then 2 plus negative 6 gives me what? Negative 4. Now when I look at it, I have an addition and I have a multiplication. So I have to do the multiplication first. And that's right, we're going to get 55 plus a negative times a negative is positive. So that's positive 12. And then we only have one operation to do. So we add 55 plus 12 is 67. Yeah, that's all right. It's fine.
So if I show my work like that on the test, I won't get one.
You'll be all right. Yeah. All right. How about this one? Sure. Absolutely. So this one is the absolute value. 4 minus 9 minus the absolute value of negative 10. It's not too bad, right? Yeah. I would agree that when you do 4 minus 9, you get negative 5, but then it's the absolute value of negative 5. There you go. Oh, nope, because that's inside an absolute value. So we would leave that alone for now. So now, though, look at your answer because you have 5 minus 10. Give you about 20 seconds.
Wait.
All right, so if you have an answer, make sure you've entered it. All right, so let's look at this one. So, on this one, we had the absolute value of 4 minus 9 minus the absolute value of negative 10. Now, some folks may have wanted to do addition of the opposite sign, but you can't do that. It's in absolute values. Okay? So we're going to have to work with that subtraction for a moment. We can if we want to. If it's inside the absolute values, we could do this if we wanted, plus negative like that. But we can't go from outside the absolute values to inside the absolute values. It doesn't work that way. So the first thing we're going to have to do is the operation within the grouping symbol. So that's going to give me the absolute value of 4 plus negative 9 is negative 5 minus the absolute value of negative 10. Now we're in step 2. We don't have any more operations within absolute values, but we do have two absolute values that we need to evaluate. So the absolute value of negative 5 is what? 5. Minus the absolute value of negative 10 is 10. And then you do 5 minus 10, which is negative 5. And if you wanted to, at this point, you could do your addition of the opposite and do 5 plus negative 10, which is obviously negative 5 as well.
So, you know how, like if that negative 10, like if it came out and it was a negative on the other side, that 10 would be negative,
So if it was over here,
Yeah.
then you could do your addition of the opposite if you wanted to. Yep. It's because we can't go from outside the absolute values to inside the absolute values.
See, I just typed that negative 5 minus negative 10, and I got positive 5.
Well, it's because you haven't done the absolute values yet. So you have to do 5 minus 10 or 5 plus negative 10. Either way, you're going to get negative 5. So what did you type into your calculator?
He typed it in just the way it was. He didn't change.
What was that?
The second one below the top, I typed that in.
Right here.
No, one more up. Yeah, that.
You typed in the absolute value of negative 5 minus the absolute value of negative 10?
Where that's on your calculator?
So if you're up here, right? You went to math, and you went and scrolled over to number, and hit ABS for absolute value. The absolute value of negative 5. Hit the right arrow. So once again, go to math. So now we have to do a minus. So then you hit math. Use the right arrow to go over to NUM for number. And there's ABS for absolute value. And then negative 10, right? And then we hit our right arrow, and we press enter. And it gives me negative 5.
Okay, so wait. So after you did it,
Hold on, I can only hear one person at a time.
you didn't do that step already. You didn't know about that.
Yeah, the reason why I normally don't go over absolute value in the calculator is because it's usually slower than just doing it mentally. So, but if you do ever want to check an absolute value, the way you do that is you hit math. And notice how math is highlighted. I want NUM for number highlighted. So I hit the right arrow. And then I have ABS as option 1. So I can just press 1. And now I can take the absolute value of anything I wanted. So if I wanted the absolute value of negative 37, I'd write negative 37. And then you have to hit the right arrow to get out of that absolute value. And then press enter. And it'll tell me it's 37. But since it's much quicker, we know that absolute values, if there's no sign on the outside, it's going to be positive. If there's a negative sign on the outside, it's going to be negative. It's usually quicker to do absolute values mentally than it is with the calculator.
So Jason, you asked one quick question before we move on to the second one.
Yeah.
Absolute value being in the 4 plus the negative 9. All you have to do to get that answer is just type in 4 plus negative 9.
And that would give me the negative 5.
Okay, and you just keep it as the absolute value.
That's right, because we're performing the operation within the absolute value.
I took away the absolute value.
Right, yeah. So we have to, and this is important, we have to perform the operation within the absolute value in the first step. But we keep our absolute value bars. It's in the second step that we evaluate absolute values. Okay? And it is time to go. So go ahead and put your clickers away. You do have new homework on this. You'll get lots more practice in your homework. So make sure that you're logging in and doing it, though. You don't want to get behind on this stuff, okay? You're okay.